Good afternoon, everybody. Right. So welcome to the session over here. We are just going to talk a little bit about the introduction before we dive right into the content. Okay. Thank you for finding your 3 hours here on your first day of your September holidays to spend with me here. What's that? For them, or you collect for them. Okay, so nice of you. Okay, so first things first, just a little introduction about myself, right? You can call me Teacher Jason, Mr. Pang, teacher, whichever you're more comfortable with. As long as you can get my attention, I'll be there to help you for this. Okay, so I'm not just a face, a person standing around in front of you here. For our friends at home, I'm not just a movie that you're watching, right? So learning is a two-way thing. I would love to hear your voices asking me questions and answering my questions as well. Yes, Kessler.
Have you ever walk fries or
Thankfully not. All right. Okay. So not something I want to share with you, Kessler. All right. So okay. I have been. Sorry.
or not?
It'll become worse if you keep on interrupting me, Kessler. Okay.
Okay.
All right. I have been teaching for 10 years or so. I hope I do not look like I have taught for 10 years. Okay. But before this, I was with the Learning Lab. I was teaching there for a couple of years, and here I am. I graduated from NUS studying life sciences, which was just the university's fancy way of saying biology. So I studied biology, right? Okay. I did a minor in psychology because I was interested in how the human brain works. Right. Very interesting thing, right? Literally, I am saying that the brain is interesting. The brain is complementing itself. All right. Okay. Just this us a little bit about myself here, about the classes there. There are so many of you, especially our online friends over here. Pardon me if I do not remember your names. I will try my best to remember your names here, especially for the friends that are here with me. But a little bit about me outside the classroom. I'm not just a voice for you to listen to or a teacher just droning on in front of you. I love the outdoors. I especially love climbing. So as you can see on the right hand side. Just climbing on the walls in Singapore. Anyone climb before? Singapore? Try on the gyms there, try before? No? No? Do you know it's a thing in Singapore? I hope you do. All right. I love hiking as well. So that beautiful picture taken there was in Australia. All right, simpler times and amazing weather, beautiful place to hike. I have had the wonderful opportunity to merge my passions for climbing and teaching. So I do teach some climbing courses as well as you can see over there. And just yesterday, I was indulging in my yet another passion as well, making music. So
I like
I
making
play.
music too.
Awesome, right? We can talk about that next time, Pastor. Right? So I'm in a symphonic band as well, and we just had a concert. Can you not interrupt me, please, Kessler? I would love to speak with you, but not when you interrupt me. Is that fair?
Sorry.
No problem. Thank you. Okay. So I'm playing in the band as well. So I like being outdoors. I like being indoors as well. So just being everywhere, lah. As long as we are doing something that we love. So why am I taking this time to share with you why I love what I do? Is because I do not want us to just look at your studies being something that you have to do, you have to get through. You find that little bit of fun that you can have, it will make your studies so much, not say likable, but bearable. Right? I am not going to say that everybody will have to love the subject to do well with it. You just have to not hate it as much, right? Right. So we're gonna take small little steps over there. If I do see you in my classes and I do get the opportunity to learn with you in future in my regular classes, every lesson, my hope is that you will like that science a little bit more or hate it a little bit less. Fair, okay? Right, so that's what we're gonna try to do. I'm not going to expect you to love the science as much as I do already. Okay, just hate it a little bit less. Okay, so while we are still waiting for a couple more people to join us here, we're just sharing with you a little bit of our information here. And we are at the Marine Parade one over there, as you can see. Very sure we are quite spread around here. Anyone stay like super far from this current location? Where do you stay, Joey? Okay. Oh, because you don't have that. Eh, we have what?
On Saturday for that one.
Make it. Okay, right. Thanks for being the trip here. Oh, I'm looking. Okay, so just for context, there are only like for combined chem bio, it's only me. That's why it's here. Only a few places. So the places I'm teaching is these three. So guess where I stay? Here, lah. That's why. I'm not gonna come here. It's too far for me. Okay, so thanks for making the trip down, for the rest of you here. Right, just sharing with you that where we are. Mostly, I'm going to Tesla once more. Okay, yes, hi. What time already? Faster, say. Hey, what am I supposed to say to them?
Oh God! I'm sorry for interrupting you again.
Ken Kessler.
Sorry.
All right, boys, names please.
Hi, plus. Just
Wait, okay, I see Wei-Han, yes. And
the second jealous.
okay, the 8900 is it?
Yeah.
Lucas, what? KH. Oh, H, awesome. Okay. Do you all have the materials? That's for you, all right. Okay. All right, so okay, basically after this event, right? This one is more for the Sec 3s only, right? Then we will have a session for the Sec 3s. For the Sec 4s, I also have my for the Sec 4s, I also have my own Sec 4 classes. So if you all wish to continue with me, you all can reach out again. Okay. So 5 of you Sec 4s. Okay, so this one is only for the Sec 3s, but I also have Sec 4 classes, so you all can think about it as well. Okay, so up to you, right? It's just lessons over here. So this is just a few of us teaching for all this stuff over here. Our centers are all free for you all to come and study in as long as within our regular hour. We're not gonna let you study here overnight. Okay, no studying here overnight, right? But as long as there are no classes or meetings held, something that the center very uniquely offers is a study space for you, right? So actually in the middle classroom, no classes going on there. They are just doing their own self-study there. So instead of rushing to Starbucks, buying an expensive $7 drink, and like scared whether or not your things will get stolen, this is a very nice place for you to study with us here. Okay, all right. Okay, I'm not gonna bore you with this because it's at the back of all your handouts. We will therefore head right into this. Okay, so before we head into this thing here, I would need a show of hands who has done the mock paper already. Thank you, Kessler. Thank you, Heiko. No, Anxia. Thank you. Hey, hello, the rest of us. The session here, right? We need to. Oh, thank you, Leisha, for the hand over there. Right. The focus here is a revision kind of thing. Is a help you tidy up loose ends kind of thing. Okay. I will definitely still be running through some of the common concepts, but truth be told, it's not going to have a lot of time here. What we're going to be doing over here is going to be 3 topics from each science and then the mock paper. Okay, 3 topics from each science and then the mock paper. So to best use our time, like I said, I would love to hear your voices as well. Walk through the concept with me. Okay? Okay? All right, especially if you are late, then I'll ask you more questions. Okay. All right. So for the first of the 3 chemistry topics, please flip your booklet to chemical bonding with me. Please flip your booklet to chemical bonding with me. Okay, please flip your booklet to chemical bonding with me. For those who have the hard copies, is the full thing, right? But we are only going to be going through the selected topics. Okay. All right. Awesome. So chemical bonding. I am going to be very succinct with this because I do not expect to be teaching anything from scratch. Is that a fair assumption? I'm not going to be teaching anything from scratch. So if I ask questions, should be able to get some answers. Correct or not? I forgot your name already. Sorry, wait. Lucas, thank you for volunteering that. No, Lucas is you, isn't it? Very good. Okay. All right. So for chem bonding, we are looking at a very simple reason. Why do they gain or lose electrons? Okay. Between the green and the blue highlights here, which one will be a more preferable explanation put down? When the question is asked, why do atoms form bonds? Full valence shell, absolutely. Because stable electronic leaves the question for the marker to see. Or you say become stable, but what is stable? Okay, so the valence shell must be full. That's what we're looking for. Full valence shells, I'm thinking of 2 numbers. What numbers do I have in my head? When I say full valence shell, 2 or 2 and 8 only. Why? Okay. So for full valence shells, this one only concerns a couple of atoms considered full valence at 2 only. What would those numbers be? What elements would those be? Elements. Which elements have a full valence shell at 2 only?
Ionic.
Element 1 is what? Hydrogen. 18. Wow. Okay, Okay, come. Hydrogen, helium, and lithium, right? These three, when they want to form bonds, right? Hydrogen will. Hi. Hey, bond, come. Please have a seat. Just sit there. Kessler, come. Give space, Alright, so for hydrogen, it becomes H2. You will see that it has 2 electrons there. Correct or not? So the valence shell there is a 2. For helium, it is stable by itself. Correct or not? Stable by itself. So also 2 as well. Helium is also a. My goodness, what's wrong with my pen today? Okay. For lithium, is something slightly different over here. It will become the lithium ion. Why? Because it will lose that 1 electron, and then it will only have 2 of its own valence electrons now. Okay. What do you have the materials here? Have okay. All right. So everything else will have to have that 8 shells over there. Okay. May I ask a bonus question here? There's a name for having 2 and having 8. The shell is now. Any words that you can share with me? This one starts with D, starts with O.
Starting cross.
No, not like cross. Alright, so to have a full valence shell of 2 electrons, you can also refer to this as a duplet structure. Okay, no, these are the bonus what I want to share with you only. Okay, alright. So if I say duplet is for 2, next one is Wei Han, come.
Yes, we can. Well,
If hey, come on, that's not what I'm supposed to be doing now. Come on.
well, it's coming here, but then it's late.
Okay, then you don't disrupt that. You either go outside or you okay. Jailer, if 2 is duplet, 8 is octet. Okay, so we are trying to achieve the duplet or octet structure, right? 2 and 8 will be full already, fairly straightforward. All right, moving on. For this one, if it's gain or lose, we are talking about ionic bonds. Again, very quickly, which ones change the number? Electrons is the only one that can change. If I want to help you remember better, proton tells me the identity. Right, that's like your register number or your index number in school. That does not change. Okay, all right. So just keep that in mind. Proton is the identity. You cannot change the proton number. Okay, because this is actually something scientists for many thousands of years have been trying to do. What were they trying to do? They were trying to change. They were trying to add 1 proton to the metal to make it gold. They thought like, oh, just 1 proton difference only. I change it. I can make gold. I can get rich. Unfortunately, that's not possible. Okay, all right. In school, we are going to be using cations and anions. If you are ever going to be confused about which one is for positive, which one is going to be for negative, one way to look at it is anions. Yep. Go anion and negative, fairly straightforward. Or something a little bit more fun over here I can share with you is that cations form are positive. You get it, right? Cations, positive. Or simply, this is a plus sign as well. Okay, so whichever works for you. Okay, whichever works for you. All right, so just keep that in mind. Please keep that in mind. And what kind of elements? What kind of elements? Libby will always do this. Will always become positive. What kind of elements? Wait, metal. Wait, who is Libby? Right. Okay, right. So metals will always do this, and then definitely this is going to be our non-metals. Okay, these are no exceptions, no exceptions. All this simple stuff, make sure we get it down. Right, so gain or lose, in this case here, we want to think of, for one word here, we're looking at transfer. If one atom gains an electrons, means another atom lost it. This process is a transfer of the electron. And we can see it very nicely shown in the diagram over here, the transfer of electrons. Okay, In this case, it's very easy. Sodium will lose its single valence electron for chlorine to have the stable octet over here. And keeping in mind, we are drawing our square brackets and stuff like that. I want to bring to everyone's attention again this portion. Electrostatic. Coming? Yes, Kessler.
So only have a one line.
Sorry?
Only have a one line. That's all safe.
Later I'll get it. We just leave it there first. No worries. Later we get it. Okay. Please keep this in mind. Electrostatic forces of attraction. As you can see on the last few words, we are looking at oppositely charged ions. Oppositely charged ions. I would really strongly recommend, right, if you are given a specific example and the question say describe the bonding, don't use the words oppositely charged ions. Instead, directly tell me, in this particular example, the electrostatic force of attraction is between the sodium cation and chloride anion. List down the ions. Can? Right? Whenever we can and whenever we have the opportunity to be specific, we say, instead of saying oppositely charged ions, hey, tell me immediately positively charged sodium and negatively charged chloride ions. Okay? Okay? Right? Just keep that in mind. So, why am I encouraging us to be more specific on this? Because EFOA exists as long as the particles are oppositely charged. Yeah, as long as two particles are oppositely charged, there will be electrostatic force of attraction. So, question, other than cation and anions, what other particles can have electrostatic force of attraction? Other than cations and anions, what other particles can have electrostatic force of attraction? As long as they're oppositely charged, can have already. Can you help me to think through your beautiful brains, please? What other oppositely charged particles are there that can have the electrostatic force of attraction? Yes? Try lah. Wrong, then we learn. Correct, then we rejoice. What other oppositely charged particles have you all encountered?
Two non-metals, like forgot.
No. Oppositely charged particles. What kind of charged particles have you encountered? What name?
Joel.
Joel, what oppositely charged particles are there other than ions? Tell me. Before you sit down, tell me. What kind of charged particles do you learn in your syllabus? That's an ion. Oppositely, yes, as well.
Sodium and chloride.
Those are ions. Other than ions, charged particles. What else? No. Come. Particles. Even smaller. Smaller, even. Hey, very simple. We are at the answer already. What's even smaller than atoms? Electrons and
Neutrons.
neutrons. Are neutrons charged? So therefore, proton lah. Proton and electron. What's the attraction called? Electrostatic force of attraction. Okay? Okay, draw attention. See, please. Okay, so again, learning point. As long as it is oppositely charged, there will be an electrostatic force of attraction. Why am I sharing this with you? Because if you look at this one, if the sodium atom were to lose this electron, the charge between the electron and the positively charged nucleus is going to be relatively weak. Okay? Do we see that? The attraction here is going to be relatively weak. Okay? Alright, so dot and cross for ionic now. Same thing, but in this case here, we have a slight difference in the ratio. MgCl2, but do we have to draw both chlorides? What can we do instead? Put a 2, please keep in mind, the 2 is central to the entire ion they are drawing, not at the top, not at the bottom, definitely not here or here. Okay, so think of this as your equation, your mole ratio in a way. Okay, your numbers must always be in front. So if I put a 2 over here, I do not need to draw my second chloride ion. Okay, all right. So that's for ionic, that's for transfer. For covalent, we are looking at the word sharing. Now, Joey, then we are thinking of the non-metals. Okay, so when two non-metal atoms come together, we are looking at them sharing electrons. Why? Based on, can I just have a thing, please? Based on the idea of electrostatic forces of attraction that I shared with you just now, why do non-metal atoms share electrons instead of one gives, one take electron? Based on the idea of the electrostatic forces of attraction thing just now. Yes.
They don't have the same number of protons and electrons. Each just has static.
Not quite. Not quite. They don't have the same number, but that doesn't explain this. Come, let's think, please. Let's think, please. Like I said before, we're not here to just get answers from me. Help me to think. Why here, non-metal, they share. But just now here, can transfer. Why here can transfer?
Because they need like 8.
That's the reason for bonding in general. But why this one is transfer, but non-metal is share?
Intermolecular forces.
Your head, I tell you this one, Focus on this one. Good try. Thank you. Sorry? Yeah, what about it? What about it? Okay, can. I'll take that. Thank you. So it's actually the strength of this electrostatic force of attraction. In a way, have a look at this. If the electron comes over here, this means that this chlorine atom is able to attract this electron stronger than the attraction is to here. Fair enough, not? If this glove over here is my electron, I'm sodium, this is my valence electron. But Joey wants it more than I want it. What will happen? That's the ionic bond already. Okay, fair enough, Right, thank you. So this transfer of electrons occurs because chlorine attracts the electron more than the sodium does. But in this case, why share? Yes.
They both have the same electrostatic forces between them.
Absolutely. So in this case, both chlorines want the electron to the same extent. I want you also want then what your mother say? Share lah. Okay, share the toys. Okay, don't give the toy to your sibling. Okay, right? So in this case, they are both equally desperate for that extra electron. So they're going to share the electron. Okay, please keep the idea in mind for the electrostatic force of attraction thing. Okay. They're going to share, blah, blah, blah. Okay, so in this case, again, I want to take this opportunity, diatomic molecules. In our periodic table of elements, how do we help ourselves better remember which elements are diatomic?
What's diatomic?
Over here, two atoms in one molecule form a diatomic molecule. If you look at your periodic table, I'm just gonna share with you these three letters.
They just so happen to be like 9, 16.
9. No, not quite. So my suggestion for you, anything that ends with a gen is going to be diatomic. Literally, think through in your head all the something gen. It's going to be diatomic. Oxygen, O2. Hydrogen, O2. Nitrogen, O2.
Wait, what's chlorine gas?
Okay, very good. Chlorine how? It's not chlorogen, Chlorine, fluorine, bromine, iodine. What are they called? The name. Halogen. That's why diatomic as well. Okay? All the gens are diatomic. All the group 70 elements are called halogens. Okay, all the group 70s are called halogens. Okay, all the gen is diatomic. So with that in mind, please never ever tell me, hey, when the question say nitrogen, then you just cannot. The moment you hear a gen, put a 2 over there. Okay, awesome. Let's go. So we are done with the ionic thing. We move on to our covalent one over here. So if I look at this one now, got electrostatic force of attraction or not? Just now, electrostatic forces of attraction exists as long as there are oppositely charged particles. So in ionic bonding, it's between opposite ions lah. But covalent bond have or not? Have. Have oppositely charged particles. Joel, come. What are the particles here? What are the particles here? They are oppositely charged. Literally in these diagrams. Your head last C and O. These are what are these things? Dot and crosses represent electrons. So if electrons are negatively charged thing, what is going to be the positively charged thing?
Negative times negative is
Listen to the question. If electrons are the negative things, what are the positive things? Protons. Where are protons found in an atom? Where are protons found in an atom? What is that called? The nucleus. And therefore, the green stuff are all positive. The orange stuff are the negative things. Where is the electrostatic force of attraction? Here and here. Do we see that? So this is the electrostatic force of attraction between the positively charged nucleus and the negatively charged electrons. So it's because O attracts those 4 electrons, C also attracts those 4 electrons. Hence, together, that is the covalent bond. Okay, covalent bond. Okay, clarifications? Can? So I really don't want to have us just, electron, that's why covalent. You got to understand what the covalent bond is. Why are they sharing it? Can? Okay. All right, so this one for the common stuff over here, like carbon dioxide, water, methane, please make sure you are able to come out with your dot and cross diagram very quickly. But do not be surprised if you see some molecules that you have never encountered before and they ask you to draw a dot and cross. As long as you stick to the duplet or octet structure, you'll be fine already. Okay, as long as you stick to your octet or duplet, you'll be fine already. Okay. Okay. Properties here, I think it's not fairly straightforward. I want to ask you again. These 3 properties is what kind of properties? MPBP, electrical conductivity, solubility. What kind of properties are they classified under? What kind of properties? Hey, we'll ask question, your head must think through some words. That's the explanation. No. What kind of properties are these? Thank you, physical. Be able to think of the correct words in your heads. Can? Right? So these are the differences in the physical properties. Why is this important? If question asks you to compare physical, you put chemical. Even if you put a correct chemical property comparison, you will not have your mark. Fair? Question asks you for physical mark. You give me chemical, no marks. You're not answering the question. Okay? Please keep that in mind. All right? What then falls under chemical properties? The moment electrons are involved, then it's chemical property. Why? A chemical property, in other words, chemical reaction. What does it mean to undergo a chemical reaction? Electrons must move around. Can? So, got electron, chemical. No electron, physical. Keep it simple. Can? Alright? So this is all for you. Let's very quickly talk about this. Ionic compounds are the only things that conduct in molten and aqueous. Firstly, Yvonne, help me. Molten is what state?
Okay.
Very good. Right, so keep this in mind. But both the words liquid and molten state share the same state symbol of L. There's no such thing as bracket M. Okay. Why? Why only? Let's hear from Rayan. Why ionic compounds only conduct in the liquid and aqueous state? Rayan? Well done, Sherry. Okay, so ionic compounds, right? They only conduct electricity when in the molten and the aqueous state. Molten aqueous, then it can move around. So that's the word to follow over there. Okay, so mobile ions, then you can conduct the charge. So therefore, in the solid or the gaseous state, all your ions are present, yes. Got charge carrier or not? Have. Are they mobile? No, cannot move. So you cannot conduct the electrical current. Can? Okay, got to keep that in mind. This is a very standard one-liner that can get you your answer. Why ionic compounds can only conduct in an aqueous molten state? Presence of your mobile ions. Okay, presence of the mobile ions. Okay. Now, this part over here, I think I'm just gonna take 10 seconds to bring to your attention. Please make sure you are writing about the correct stuff. In ionic compounds, only got the EFOA to overcome. In ionic compounds, only overcome EFOA, whereas in covalent substance, overcome the IMFOA, the intermolecular forces of attraction. Ladies, please. Okay. However, at this point, right, can I suggest a slight optimization in our phrasing over here? I will underline for you. You tell me how to optimize.
Wait, what do you mean by optimize?
There's something that we can do to this part that I've underlined to even shorten the sentence, but still carry the same message.
Remove intermolecular.
Why? No. No. It is to remove something. Remove what?
The
No. The meaning must still be there. Now, what does this mean? What does intermolecular mean?
between molecules.
Between the molecules. Then, you see it? Do we have to say intermolecular forces of attraction between the molecules? Hey, you look very confused. You understand not? The word intermolecular means between molecules, really. Okay?
We remove between the molecules.
Absolutely. Remove between the molecules. That's fine. Okay? Okay? Unless you are specifying, weak intermolecular forces of attraction between chlorine molecules. Okay. Okay? All right. Okay, let's go.
You still have to like having the ion.
Yes. Okay? Can? Okay, formulae. Okay, let's do a quick exercise over here. Let's do a quick exercise over here. Okay, give me the chemical formula of these two ionic compounds, please. Potassium carbonate, calcium nitrate. Write it down on your handout, please. Potassium carbonate, calcium nitrate. Give me the chemical formula of these two ionic compounds, please. For our friends at home, please feel free to just type it into the chat, right? My chat window is open here. If you wish to be part of our learning together. Jayla, help me with the first one, please. K2CO3.
Don't forget the 2 minus on top, the CO3.
Okay, so that's where it's wrong. When we are writing the chemical formula, Kessler, there are no charges. All right, chemical formula has to be a sum of 0. Okay, right? So the carbonate ion is CO3 minus. But when we put it together in a compound, Jayla is correct. K2CO3. Thank you. Okay. Let's hear from. I go. Calcium nitrate. Try lah. Wrong, we learn. It's okay. Calcium nitrate. That's it. Okay, we take the clues over here. Ca, NO3. Ca is a 2 plus, NO3 is a minus. Basically, we need to sum them together into a 0. How many nitrates do I need? Balance out calcium 2 plus. A single nitrate has a single negative charge. Here is 2 plus. Total, how much minus do I need? 2 lah. So how many nitrates do I need? 2 lah. So therefore, calcium nitrate, Ca. Wow, what is my pen doing today? Okay, you have to bracket your nitrates to get the 2 over there. Alright? Yes, very good, Leisha. Thank you. Alright, so for ionic compounds, there's a neat little trick which I believe that most, if not all of us, should be aware of. Is the crossing of the numbers thing. Are we aware? Do you know what I'm talking about? The crossing of the numbers? No, awesome. Thank you for your answers. Okay, so for the names, I want to highlight this thing here. What is the significance of this?
It shows the charge.
It tells us the charge. Why the others don't need? Why the others? Why don't I need to say aluminium 3 nitrate, potassium 1 sulfate? Absolutely, Kessler. We must have the bracket Roman numerals for cations that exist in more than one charge. Okay, so Dini, other than copper 2, what other charge does copper exist as? Don't go up, go down. Copper 1. I've never heard of copper 3. You all got hear of copper 3 before? Okay, so copper exists as copper 1 and copper 2. Copper 1 and copper 2. Why is this important? Because if you look at this particular case, copper 2 hydroxide is but copper 1 hydroxide. Do you see how different it is? The formula? Okay, the copper 1 and copper 2, very important. Okay? Alright, copper 1, copper 2, very important. Come, what other metals have this variable charge? Iron, Fe, 2 plus and Fe, 3 plus. Wonderful. What else? Come, quickly. Copper, iron, lead. Thank you. So in our syllabus, lead, we only have 2 plus in our syllabus. But it does exist as others. So you have to state lead too. Okay? Alright, please keep this in mind. The moment you don't put the bracket there, your name is incorrect. Fair? Your name will be immediately incorrect if you don't put the Roman numerals there. Okay? Awesome, let's go. So for covalent, you realize there's no such thing as your bracket Roman numerals. There's no 1, 2, 3. Okay? But what is interesting over here is, look at the bolded and underlined portions. You will only have monoditri tetras for covalent substances. The easiest one is what? Carbon dioxide. Immediately, the moment you have the monoditris, is a covalent compound already. Okay? Oh, yes, you're right. Come, say. Rehan, what do you find out?
What?
Well done, Rehan. Okay, so please make that change for me. If your handout is wrong, please make that change for me. You want to change to sulfur dioxide or change to carbon dioxide, up to you. Okay, as long as you understand what the error is. Okay. Okay. Let's go. Equations. So this is a build up. Why we need to make sure that our formulae are correct? It's because if your formula not correct, your equation cannot be correct. The formula is more important first. Okay. So over here, some of us may have learned many different strategies in balancing, isn't it? Okay. Stick to what you know if it works for you. But if it does not, later I'll share with you. Okay. So a hydrogen and oxygen. So when the question just says hydrogen and oxygen, will it ever mean H plus O? Give me H2O. It will never mean this. Why? Hydrogen. No. Hydrogen. Gen means what? Oxygen. Okay? You will never a single H or a single O. Okay, yes, guess what?
Where does the second oxygen atom go?
Exactly. That is what we're trying to do in this exercise of balancing equations. That's it. You're just gonna math it out. The only thing you can do is multiply. You can never add, you can never subtract, you can never divide. That's gonna multiply. A fairly straightforward one is you're gonna put 2 over here on the right hand side. I will now have 2 oxygens and 4 hydrogens. Therefore, this is it. Okay? Okay? For the next 2 lines here, let's enlist the help of who's here? Let's see. Lucas, chlorine. Sorry, louder, please. What's the name of Cl minus? Louder? Chloride. Okay? No, don't apologize. You can do better, okay? Come, let's pass it on to our friend Joel. Potassium iodide. Hey, first. If it's not in your head, you can look here. Do we have a potassium over here? Joel?
Yes.
Then iodide. Iodide is in the same group as what? Chloride. So if chloride is Cl minus, iodide will be I. Say. So K plus and I minus. What is the formula? Ki. It's just Ki. Okay. Okay, potassium chloride. KCl. Iodine. Is it just gonna be I? Why not? Iodine is a?
S2.
S2 is a diatomic molecule, is a halogen. Okay. Come, let's balance this. How do I balance this? Brian, your answer is? Correct or wrong? Why wrong? Yeah. Brian, do you miss out on this? Iodine is already I2. So this is actually the perfect example. Thank you for letting us work on this mistake, Ryan. Okay? If we missed out on this I2, then it will make us have to do this to balance. Okay? Do we see how an error in the formula writing will lead to an error in the balancing? Okay? Formula must be correct. So because we know that iodine is I2, we don't need this second 2 over here. Okay? Can someone tell me the name of this reaction? Wonderful, Lucas.
Yes.
Okay, so this is the displacement reaction. Libby, explain displacement reaction, please. When a more something, before, when a more reactive, very good. Okay, hold on. A more reactive metal displaces a less reactive metal from its compound. But this is not metal displacement. This is what? Who is doing the displacement here? Halogen. The concept is the same. You literally just change the word metal to halogen. Okay? Displacement reactions occur for 2 things in your periodic table. Displacement of metals, displacement of halogens. The concept is always the same. More reactive displace less reactive. Okay? Thank you, Libby. All right. Last one. Sodium plus water. What is sodium? Nah. Plus. No. When do we include ions in our equation? What kind of equation then we put ions? Ionic equation lah. Okay, chemical equation, no ions. The only time you write down ions is in the ionic equation. Okay, so sodium is Na, water is H2O, sodium hydroxide. Sodium hydroxide. Joey. Hydrogen is H2. That's it. That's what we're trying to do. We're just gonna balance here. Can I just share with us here that for chemical equations, we dislike odd numbers very badly. We absolutely dislike odd numbers. So we can see that right side is the one with odd numbers because I have 3 hydrogens in total here, isn't it? All right, I want to make it even. How do I do that? My hydroxide there. All right, I multiply 2 over here. So now I have how many hydrogens? What?
So there's three.
Where got 3? Where have I written the number 3? 4, 4. I got 4 hydrogens over here. I only have 2 over here. What do I do? That's it. Okay, so if I have 4 hydrogens in total, my hydrogens are done. 2 oxygens, just nice 2 oxygens. All I need to do is sum it up over here like this. Okay? Okay? So once more, what is the name of this type of equation that you've just written down? Chemical equation, When then do we put ions? Ionic equation. Okay? Ionic equation. What is the meaning of spectator ions? What are spectator ions? What are spectator ions?
Plus and minus and plus and minus equal.
Plus and minus are just ions. What are spectator ions? Spectator ions are something that we are trying not to be in class here. We want to be involved in learning. Spectator ions are not involved in the reaction. Do not be spectators. Correct, not Joel? Okay, so let's take a spin on this. Coral asks how to know the state of compound, like the state symbol. So they give us this over here, right? You want to try? For this one, these 3 things, what are their state symbols?
Gas what?
Wait, gaseous, liquid. Very good, liquid, Okay, gaseous, liquid. So, how do I know this? You need to be able to identify what is the substance's melting and boiling point. If the question does not state, then you look at it in terms of room temperature. What is room temperature? What is room temperature? What number is it? 25 degrees Celsius, right? In your syllabus, you must always have 2 temperatures in your heads. Room temperature is 25 degrees Celsius. What is the other temperature? Yeah, there needs to be 2 numbers in your head. Room temperature 25 degrees Celsius. The other temperature is body temperature. What is that? 37. Okay, always have these 2 numbers in your head. Can always have these 2 numbers in your head. 25 degrees Celsius for room, 37 for body. Clear? Alright, so we are looking at the most important one is this one. Solubility. Solubility. Okay, the solubility of a substance. This is something that we need to keep in mind. Go and look up your school notes over there for the solubilities. Okay, it's an entire beautifully crafted table that we have in our curated notes that you will have access to if I do see you in class next time. We don't have time to look at it enough. Okay, come, we're gonna move on to acids and bases now. Acids and bases. Right from the start, we must ensure that we remember the definitions over here. And acids is H plus, alkalis is OH minus. Okay, and it must always be dissolved in water. So, very. What is this? What is this?
Hydrochloric acid, solid state.
So, listen. Read the definition of an acid again once more. Okay, then what would this be now? This is actually hydrogen chloride powder. We only call that substance an acid if it has acidic properties. When will that something have acidic properties? Only in the aqueous state. So if they give you, well done, right? Yes, you love chemistry. Okay, when you have HCl gaseous, hydrogen chloride gas, HCl liquid, hydrogen chloride liquid, HCl solid. None of these things have acidic properties. Only in the aqueous state, then we'll have acidic properties. Why is this important? This explains to you why it's important to have moist litmus paper. Okay? This explains to you why must moist litmus paper.
Like in water, dampen it when you're dealing with
What it?
dampen it when
Yeah,
you're dealing with
correct.
gas or something.
Yes. Acidic gases. Okay. Right, so this explains why the litmus papers must be damp, right? It will only have acidic properties when aqueous. Okay. Same for the alkalis. All right, so please remember the names and the formulae of the common acids and alkalis. Okay, your hydrochloric, your sulfuric, and your nitric, as well as your two hydroxides, as well as your aqueous ammonia. Okay, sometimes, can we just add this in as well? Sometimes aqueous ammonia can also be represented as this. Sometimes aqueous ammonia literally described as this.
Why?
Just the difference in your syllabus here. Your syllabus doesn't want to overcomplicate it, so we show you either forms. Nowadays, this one is more common, right? Just know that they both refer to the same thing. Okay? Now, the next thing over here. Listen to this sentence. All neutralization reactions. Come, listen to this, please. All neutralization reactions have the exact same ionic equation. No matter what acid, no matter what alkali, this is the ionic equation. Okay, no matter what acid, no matter what alkali, this is the ionic equation. Okay, so this is a quick trick for you to get to the ionic equation. Okay, all right. Okay, your four reactions that you learned in this topic of acids and bases. Three of them, we have the acids one. So we have three acid reactions. How many alkali reactions do we have?
No.
From this list here, we have three acid reactions. How many alkali reactions are there?
No.
There are actually two. One is written over here. Another one is?
The neutralization.
Very good. Do we see that? Okay, so the acid-base reaction is for both acids and bases. Okay, so that we learn three acid reactions. We learn two alkali reactions. Just that they overlap. So how many different reactions do you learn? Four only. Okay, three for acids, three for alkalis, but they overlap. So only got four different ones. Okay? Okay? Right. If anyone struggling to understand the amphoteric one, why it react with both, the word comes from the ampho here over here. What animal comes to mind? The amphibians. That's it, literally. Use this to help yourself. Amphoteric, both what? Amphibians, both land and water. So amphoteric oxides can react with both. Right? The mnemonic we use is ZAP over here. So basically, Jayla, help me over here. If zinc oxide is reacted with hydrochloric acid, what is the role of zinc oxide? It's a basic oxide. Okay, very good. It just does the opposite thing. Right, Lucas? If aluminum oxide reacts with sodium hydroxide, aluminum oxide is the acidic oxide. Weihan, if lead-2 oxide reacts with zinc oxide, what happens?
Acidic.
Nothing. Both amphoteric, my goodness. Okay, lah. So if the amphoteric reacts with acid, I become the base. If the amphoteric reacts with base, I become acid. Clear? It will always be the opposite. Don't get tricked, huh? Alright. No, stop apologizing. We're here to learn, okay, Rihan? Alright. Okay, no, apologize for that. Alright, so just please remember, we start with these two first. Okay? Literally the sentence I want to share with you the most easily is all metal oxides are basic except for ZAP. We use this sentence to help you remember. All metal oxides are basic except for ZAP. Except for Z. Likewise, the sentence is all non-metal oxides are acidic except for this.
Yeah.
Okay, Hey, if the metal oxides, I have ZAP to help you remember as a trick here. What about this? The trick here is, actually I'll write it this way. Why am I writing it down this way? Because literally the sentence I want to share with you here is, what are the neutral oxides? No cold water. If you just kind of like mouth it off like that, it runs out a little bit better. No cold water. Right? No cold water. These are the three neutral oxides. No cold water. Okay? Are the neutral oxides. As a strategy to remember the three neutral oxide. No. Sulfur is an ion too. Yeah? Okay. Hydroxide. Here's hydroxide. Okay, that's it for the chem portion. Let's quickly hop over to the bio portion. For the bio portion, we are going to look at biological molecules. Biological molecules first. That's sulfur dioxide, yes? That's an acidic oxide. Okay, let's go to biological molecules now. Alright, as I shared, just for the sake of those who join us a little bit later here, your notes have all the subjects there, but we're only going to be focusing on these three, okay? Come for bio, let's get on to biological molecules. Biological molecules. Now, show of hands, who uses these three terms in school? Got use these three terms in school? Thank you. Have? Twice? No? Yes?
No.
Why one yes, one no? Different school? Oh, okay. You all use this?
We go use monosaccharide now. When?
Okay, simply put, come. Can I share with you here? Basically, the monosaccharide is... Yes, Joel. Okay, so if I were to just again explain to you a little bit, let's not just blindly memorize stuff. What does monosaccharide mean? Mono, everybody should understand, is one. Saccharide is loosely translated as little sugar. So quite simply, 1 little sugar, 2 little sugar, many little sugars. That's it. Okay? Why is it 1, 2, and many? Literally, these three is 1 unit of sugar. When you put 2 of them together, disaccharide. Poly is when you have many of them. Okay? Many of them. Now, quick question. Need to memorize all 9 or not? Must remember all 9, okay? But don't like, wow, 9 things so much. That's why I cut it up into 3 for you. Okay? We cut it up into 3. This portion over here actually is the easiest. Why? You have encountered this first mark in primary school. Why not? Starch, okay? Alright, so both of these, starch and cellulose, are both similar in terms of what? Help me recall, please. They are both flying plants. Wonderful, thank you. However, starch and glycogen are both similar because they are used as... They're used as... No, they're not used as energy. Storage. Okay, they're used as storage molecules. Okay? Right? So there are two ways to differentiate our polysaccharides. Where are you found in animal or plant? Another way is, what are you used for? Storage or structure? Okay? All right, come. Moving one step in. For our 6 sugars now, keep in mind, these 6 things, you can refer to them as sugars, not sugars. Simplest explanation. Sugars taste sweet. Sugars taste sweet. These 6 taste sweet. These 3 do not. Okay? Alright? Now for these 6, if immediately I want to ostracize sucrose, tell me why. If I ostracize sucrose from these 6, tell me why. Quickly, come, let's go. Sucrose is the only non... Hey, nobody. Come, quickly, tell me. Oh, I think I heard it. What is it? Was something muttered there? Sucrose is the only non what? Rehan,
Yes.
what?
So,
Sheila?
reactive. You're not reacting.
Okay, tell me what's the word that comes immediately after this phrase. Benedict stands for? Yeah. Well done, Isabel. Hello, hey, Lisa. No, Isabel here. Here, online. Okay, so for your syllabus, you don't have to be able to explain what is the reducing or non-reducing. You need to be able to identify only, that's all. So, no, Kessler, listen, you don't have to be able to explain. In your syllabus, you just need to identify. Okay? Okay, please remember, sucrose is the only non-reducing. So this means that all 5, they are reducing sugars. Okay? What about these 3? Will there be a color change with Benedict's? No. Why not? They are not even sugars. Remember that? They are not considered sugars at all. Okay? Okay, all right. Can you tell me where does this occur?
Like a cell.
Where? Come, be more specific. Mitochondria. Okay, mitochondria. Come, let's go. Hey, hello, the word already there on your paper, no? Reducing sugar. Huh? Okay, so Benedict stands for reducing sugars. Please make sure we are able to remember the colors involved. Okay, please remember the colors involved. Okay? I trust that everybody has done Benedict's test before. Have Yes? Yes? Was the colors before? Okay? Okay, awesome. Let's go. So this is what we talked about just now. This is what we talked about just now, right? For the storage versus structure, as well as plant versus animal. Okay? But I want to stress this. All the polysaccharides, how are they similar? They are all made of glucose molecules. All of them. Okay? Alright, all of them are made of glucose molecules. The only thing that's different is what? Come, give me a word, please. How are they different? What was that? Very good. Structure. Okay, well done. Right? They are structurally different. It's the how the glucose come together. The difference. Okay. All right, iodine test. Now, this is the first food test that you all have encountered since primary school, and it's the only, please listen, the iodine test for starch is the only test that can be done directly on a solid sample. All your other food tests must be done on an aqueous solution. Okay? Iodine test is the only one that can do on a solid. The others must do on the liquid, aqueous sample. Okay? All right, fats over here. The word fats versus lipids in your syllabus are interchangeable, but technically, Which one is the bigger classification? Which one? Which Venn diagram is correct? Which Venn diagram is correct? Purple or blue? Purple. Okay. All right. All right. Thanks. Very good. What are the types of lipids here? Very quickly, I just share with you. Our cell membrane are made out of a special type of lipids called phospholipids. Okay, don't need to know right now. Absolutely don't need to know. But I just want to share with you this interesting point. Lipids or fats have taken on a very bad name in social media. It's like, wow, fats are bad to eat. But we literally we literally will not be alive if there are no fats. The lipids make up our cell membranes. Think about it. If the main component of a cell membrane is a fat molecule, if you don't have fat molecules, no cell membranes. If there are no cell membranes, there are no cells. Without cells, there will not be life at all. Okay? Okay? All right, come, let's move on. Okay, let's move on. Okay, ethanol emulsion test. I have come to realize that a lot of us are not really sure what to add to the food sample first. Always make sure of the order. You add ethanol to the substance that you're testing for first, and then add the residue to water. Okay, always add the ethanol to the food substance that you're testing for first, and then you add it into water. Always keep that in mind. Always remember, fats, lipids, oils, they are friends, they stick together, they do not like to mix with water. That is why when you all have soups and like your steamboat, the oil floats above the water. Okay, so that's the reason. Think about that. It is the exact property that allows us to perform the ethanol emulsion test. Fats stay by themselves, water stay by themselves. When there is a separation, you see it as that white emulsion. Fats are present. Okay? Fats are present. Come. Trick question. I already give you a clue, it's a trick question. Which test do I conduct when I want to test for the presence of lipase? What test do I conduct to test for the presence of lipase? Sorry? Why? That's fair. Okay, it's a burette test. Why burette test? Thank you. Thank you for saying that. Okay, a very common overlook is lipase lipid okay ethanol emulsion test. Incorrect, right? That is the exact explanation we need. Well done, Rian. Lipases are enzymes which are proteins. Then you say, red test for protein. Can? Okay, well done for not getting tricked. Let's continue. Okay, so proteins over here, just keep that in mind. The basic unit is, yes, lipase, ACE. When you have the lipase sound, it's an enzyme already. That's for later on. Okay, we'll talk about it later on. Sorry?
How was life?
No, there are two different things, Tesla. Look at my screen now. There are two different things.
Lipids are molecule but lipase is
It's an enzyme. Yes. Okay. All right, come. Hey, for the basic unit over here, all you need to know about the basic unit of a protein is that they are made of amino acids. What are amino acids? As the name suggests, the amino and the acid group. For the Sec 4, this one is more familiar to you. Right, the amino and the acid groups. Okay, for us, for Sec 3 here, we just need to know that, okay, amino acids, that's it. That is as much as you need in your syllabus. Let's not overcomplicate things. Okay? Okay? What? Okay, come, let's move on. The burette test, again, make sure the colors are there. I need to bring to your attention this one. let's pay attention to this. The burette test actually tests for the bonds between your amino acids. So if you have a solution of just amino acids, they are not bonded, there will be no color change. Okay, keep that in mind. Okay, enzymes. Definition. Definition, very important. So your first sentence over there, I would actually go even further to say that I want to add in this portion to the definition. Right? So for a definition question of enzymes, please make sure biological catalysts, speed up chemical reactions, remain unchanged. Remain chemically unchanged. Okay? Eat lah, yeah, you can eat. Don't need to hide. Okay? Okay, so to help us understand the enzyme thing better, I want to just have you think about the concept of handshakes. Okay, just think of the concept of handshakes. If I were to ask everybody to shake hands with everyone, do we need 16 different hands? Don't need, because your hand can be reused for each handshake. After disinfecting. Alright, but that's the idea here. Right? They remain chemically unchanged. Okay, so even if there may be slight changes, you curl your hands up, they will still remain back to that original shape there. Okay? Okay? Alright, let's move on. Okay, lock and key. Lock and key. Please listen up for this. If a question asks, between the amylase and starch, use the lock and key hypothesis to explain. Okay, listen up. When the question says, use the lock and key hypothesis to explain the action of amylase on starch, your opening sentence must be to identify your lock and your key. However, we cannot, please listen, we cannot say that starch is the key and amylase is the lock. They are not actual locks and keys. The lock and key hypothesis helps us to understand the mode only, how they work. So instead of saying is the lock or is the key, they say we use the word represents. Right? Starch represents the key, while amylase represents the lock. Okay? Please pay special attention to complementary. Please pay special attention to complementary. Okay, so question over here. Why does the substrate enter the active site of this enzyme? What allows the substrate to enter the active site here? The substrate is complementary to the active site of the enzyme.
On the shape of
Doesn't matter, we just keep this for now. Okay, so that's why it's not identical. The word is complementary. Okay, so again, keep this in mind. The substrate enters the active site because it is complementary to the active site.
wait,
To see whether, yes, it is not.
so
To see whether or not you are fully understanding this concept, can you all tell me why the product exits the enzyme? Flip it around. If substrate enters because complementary, products exit because absolutely. Okay? Substrate enters because complementary, products exit because no longer complementary. Okay? Alright, just keep that in mind. Okay. Enzymes and their substrates, their names are very closely related. But there is one out here, isn't it? Which one is it? So why is it not called like starches? Okay. Okay, you're not going to be asked to explain this. Can I just explain to you this? Right? So actually starch got two types. One of them is called amylose. That's all. Okay, so one of the types of starch is called amylose. That's why the enzyme is called amylase. Okay, but in your syllabus, starch and amylase, that's it. Clear? Okay, if any of you are ever wondering why it's not called starches. All right. Okay, moving on. Very briefly over here. There's the word amylase is derived from a specific type of starch called amylose. Okay, that one don't need to know in your syllabus. I'm just sharing this tidbit with you. Okay. All right, come. So, enzymes are going to be affected by temperature and pH. I need to stress this. This graph is symmetrical, meaning pH increases or decreases away from optimum, the effect is the same. What happens to enzymes away from optimum pH? What's the word? Denature. Yes, yes, sir. They deform, very good. They change their shape to denature. So I need to have your attention here. The moment I move away is denature. However, if you look at my green highlight over here, if the green highlights represent denature, but for temperature one, only this side is denature. Only this side is denature. So what happens to this other side? It is something that
Freezes. I mean, it becomes less active.
very good. What we're looking for is the activity. So away from optimum pH, denature. Above optimum temperature, also denature. But below optimum temperature, they're inactive. They become less active. Okay, they become less active. So the story I want you to have here is to denature is to be dead. Whereas to be inactive is just to be sleepy. Can I reactivate an enzyme that has been inactive? Just like how I can wake you up when you're feeling sleepy. Right? However, if the enzyme has denatured, it is dead, I cannot bring it back to life. Can? Alright, please keep that in mind. We have 4 regions over here, above, below. However, for enzymes, as long as you're away from optimum pH, denature already. Okay? Okay, let's move on to digestive system. Okay, come. Hey, come. Okay, what is the difference between the alimentary canal and the digestive system? What's the difference between alimentary canal and digestive system? Difference? Alimentary canal and digestive system? Okay, simply put, the alimentary canal food passes through organs in the alimentary canal. Joel, if the pencil is more interesting than me, then I'm not doing my job very well. Okay, come, please keep this in mind. The alimentary canal is where food enters, food passes through. But there are 3 organs in the digestive system. There are 3 organs in the digestive system that doesn't pass. I'll think about which one they are. So this is now what are the 3 organs? Pancreas, liver, and gallbladder. Thank you. Goodness. That is mine. Okay, pancreas, liver, and gallbladder. These are the 3 organs that are not considered alimentary canal, but they're very important for digestion to occur. Okay, so I put it out in this table here already. Very, very self-explanatory. I'm not going to look at every single organ. Y'all should know by now. What I want to bring to your attention here is, okay, let's just ignore some things first. The materials are with you, so y'all can follow along first. is this one. Peristalsis. Peristalsis occurs. Can I look at the esophagus, please? Peristalsis occurs as long. Listen up. Peristalsis occurs as long as it is a cylindrical muscular tube. Can we have the image in mind? Peristalsis occurs as long as it is a cylindrical muscular tube. Can you understand that? Cylindrical. It's like a straw. It's a cylinder shape, made of muscles, and it functions as a tube. To see whether or not you can truly understand this, what other organs in the body does peristalsis occur in? So you have the esophagus, you have the large intestine, small intestine. Anything else? There's one more organ in which the sectors would have learned already, this one the sectors have not, but based on what I have just told you, you all can tell me what? In the body. Anus is an opening only. Thank you for thinking about that, but it's not. Rectum is just a bag to store feces. Why? Trachea doesn't move. It just remains open. The cilium, but not the entire trachea moves, correct or not? Okay. Come think, another cylindrical muscular organ. Arteries do not do that. No, not blood vessels. Come, let's think. Locate another cylindrical muscular tube.
Small
intestine what? That was small intestine what? Not blood vessel. Oh, 明白. That one is trachea what? That's our nose. Come, friends at home, any answers here? It has to be a narrow muscular tube. Literally, it looks like a tube.
You say it again.
Not blood vessels.
Again.
What other organs does peristalsis occur in? We already listed small intestine, large intestine, esophagus.
Stomach.
Okay, stomach is a special type of peristalsis. We call that churning instead. Okay, what else? Hey, this is a very simple one. Very, very, very simple. Narrow muscular tube. So, narrow muscular tube. However, that's the correct topic. Why?
Can you say that? Yeah.
Incorrect. Yes. In primary school, you all call that one what? Fallopian tube, right? Why? Say that now. Narrow, muscular, tube what?
That's sort of.
Alright not? Okay, get your head out of the gutter. Okay, so the oviduct, otherwise known as the fallopian tube, also has peristalsis. Okay, also has peristalsis. As long as it is what? Narrow, muscular, cylindrical muscular tube. Okay. All right. Thank you for thinking about it with me. All right. And very importantly, independent of gravity. Okay, independence of gravity. Come, let's move on.
Wait, so that's not depend on gravity.
That's not. Okay. So on this page over here are the three sensory organs, associated organs in which food does not enter, but they play a very important role for digestion. Okay. I want to pay special attention to this. Okay, amylase over here. Come. How many types of amylases do we have in our body? 2. First one is listed over here, pancreatic amylase as well as salivary amylase. Well done. Okay, there are only 2 amylases in our body, salivary and pancreatic. Okay, please keep that in mind. Okay? All right, this sentence over here. Question, will there still be bowel if a person's gallbladder is removed? Everybody answer wrong, huh? Bowel is produced by the liver. Yeah. If the point of production, nothing wrong, it will continue to be produced. Fair? Gallbladder only stores temporarily for release. So without the gallbladder, liver will still produce. Just that there's no regulation anymore. The moment the liver produces, it will enter the small intestine. No regulation. Got bowel not? Have. So what's the purpose of the gallbladder? Right now, at this point in time, none of us require high amount of bowel release because there's very little fats to be digested in the small intestine. Listen, boys. There's very little fats to be digested in the small intestine. However, after a meal, the duodenum says, hey, high fat intake, let's release more bowel. It is only because of the gallbladder that we can regulate bowel release. The word is regulate. No gallbladder, still can have bowel. But the moment there is no liver, then no bowel. Can we have that in our heads, yeah? Can? Okay? Yes? I go yes? Yes? Okay, very good. Okay, move on. Small intestine. Now listen up. The words over here. Duodenum, jejunum, and the ileum. Specifically, listen, in your syllabus, these two parts only. But I have no idea why. Because your small intestine is split into three parts: duodenum, jejunum, then the ileum. Can your syllabus say specifically, yes, please teach your students duodenum and the ileum. Then the middle part. Okay? Right? So just keep in mind, they want you to focus on majority of, what did I write down over there? Majority of digestion for the duodenum. D for digestion, D for duodenum. By the time food exits the duodenum, more or less, no more digestion happening. Okay? By the time food leaves the duodenum, no more digestion already. What's going to happen next then? That's it, absorption. Okay? So the majority of small intestine left is for absorption really. All right. What is absorbed in the small intestine? Yes. Use that to remember instead. Everything except for things that you could not have digested. So in your syllabus, you need to remember for me one thing that you cannot digest. But we need to eat it. Yes. Lucas? Oh, who was it? Fiber here. Well done, Michael. Thank you. Fiber comes from what? Plants. Plants matter. Okay? Yes, fruits come from plants. Yes. Yes. Okay? So fiber, so keep in mind, the easier way to remember what is absorbed is everything except for what we cannot digest. Okay? 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 So keep that in mind. So with that in mind, can I ask you, large intestines function is what? Since primary school learn already, right? Absorb. Excess water and mineral salts. Thank you for saying that word there. The word excess is very important. Why? Let me ask you. Small intestine got absorb water or not? Then who absorb more? It is still the small intestine. The large intestine merely absorbs anything else that the small intestine had not have the chance to absorb. Okay? Literally, small intestine is what that absorbs everything that the body needs. Large intestine is, hey, still got some more. Do you need or not? Need, I absorb for you. Okay? Okay? So what happens when the large intestine is too active? And then the peristaltic action very fast.
Constipation!
No, too active. Too active means what? It flows through too quickly. What's that? Diarrhea. Constipation is the other way. Okay? Someone asks, when a gallbladder is removed, what diet change must happen? Tell me. When a gallbladder is removed, what dietary changes must take place? Why? Continue. So why must reduce fat intake? So what happens with rate of fat digestion? Okay, please keep this in mind. Very, very common mistake to make is, oh, no gallbladder already, must eat less fat because I cannot digest fat. I still can digest, just slower. Okay? Okay? Right, someone to answer your question there, we have to reduce fat intake. Okay? Thank you for asking that question here. Large intestine, blah, blah. Okay, liver functions, a lot of them over here. The biggest portion, can I have us just focus on mostly 2 and 3, please? Focus mostly on 2 and 3. The first one, we looked at it in terms of the digestive system portion already. Okay, 2 and 3, we want to focus on this. Blood glucose regulation. Blood glucose regulation. If your blood has too much glucose, I will store it for you. If your blood has not enough glucose, I top up for you. The idea here is a bank. That's it. We do not want to be walking around with like thousands of dollars in our pockets, right? So if we have too much of it, we put it into a bank first. We only take it out when we need it. That is the idea of the glucose storage in our liver. Okay? And then amino acids, we cannot store them. So we have to break it down. The name of the breakdown process is deamination. Okay, deamination. But like I said, of the 5 functions over here, just focus on 2 and 3.
Well, why can't it store amino acids?
It is too toxic for the body to store it in that form. Okay? Alright, so just focus on these 2 points mostly. Right, I'm just gonna jump to the blood glucose one here. I want to bring your attention to this graph over here. Alright, so for this graph, we are looking at 2 hormones, insulin and glucagon. Insulin and glucagon, they are released by the pancreas. Okay, so right at this point, we realize that, hey, the pancreas actually pretty amazing. It has its digestive role as well as its regulatory role. Okay, the pancreas is a pretty amazing organ there, right? It has its role in digestion. It has its role in regulating blood glucose. Okay, right? So simply put, I want you to look at this green box over here that I've labeled as healthy range. Now, look at my hand over here. For example, if my thumb and index represent the healthy range of glucose in my blood, if it changes like this, nothing will happen. Nothing will happen. Only when it rises above the maximum or falls below the minimum, the body says, hey, I need to take action. Okay, the easier story here is when you move around in your house. When you move all the way to the door only but never go out, your mother will scream at you. But the moment you try and open the door and get out, away, then action has to be taken. That is maximum and minimum. Okay, that's the idea of maximum and minimum. Okay, changes within the normal range will not result in any action taken by the body. Okay, right? So therefore, we are looking at how an increase above the healthy range brings about actions to decrease it back to the norm. Likewise, how a decrease below the norm will bring about actions to bring it back up to the norm. Okay? Right? The ideas here are very simple. I just need you to spend some time on your own to look at the how. Okay? The specific changes there. Clear? Okay? Okay, move on. So basically, what I just went through with you is just these few paragraphs. We're going to move on over here. Very quickly, let's talk about diabetes over here. Very quickly, let's talk about diabetes. Now, diabetes is when... Make sure you check the floor later. Okay? Diabetes is when what organ is not functioning properly?
The liver.
Okay, it's the pancreas firstly. Alright? The liver is where excess glucose is stored in. But what regulates blood glucose is the pancreas first. The pancreas see, hey, too much, I release insulin. too little, I release glucagon. So when I cannot regulate, is the pancreas not functioning properly. Okay, go on, follow please. Okay, right. So keep this in mind. We're looking at that. Over here, which one? Look at the problem and the cause. Look at the problem and the cause, please. Which one is more prevalent nowadays? Which one is more prevalent? Type 1 or type 2? Type 2 is the more prevalent one. Why?
Much.
Literally, yes. Right? The easy access to non-nutritious food like snacks. And yeah, McDonald's lah. Okay, so it's like that. Right? So the idea is always excessive consumption is a problem. It is not consumption. It is fine to snack. It is fine to eat McDonald's once in a while. Okay? If your conversations are more interesting than this letter here, then I'm really questioning why you're here. Okay? Okay? Alright, so let's move on. Okay, the last one, transport in humans. Transport in humans. Let's break down this word here. Cardiovascular. Broken up into two parts. Cardiovascular.
Heart.
Cardio is heart, very good. What is vascular? V for vascular, V for vessels. Okay, fair enough, right? Cardiovascular system is literally how the heart uses vessels to transport the fluid, which is the blood. Okay? Right? So the cardiovascular system is how the heart uses vessels to transport blood. Right? So therefore, if you think about that description, it literally tells me all about the system already. We have the fluid, we have the mode of transport, we have the how it is transported through, we have the thing that pushes the fluid throughout the body. Okay? Right? So we're just gonna use this over here very quickly. I want to look at this part over here. Thankfully, our blood does not look like this. How do we get to this point? How do we get to this point of blood? Any ideas? No. How do you get to this point of blood? What must I do to a unit of blood first for it to separate like this? Okay, this one is a separation technique. It's called centrifugation. Right? Not your syllabus, don't worry. But basically, this is the heaviest portion of blood. Your red blood cells are the heaviest portion in your blood. Yes, that's the well done. Okay. All right. If you were to just use one word to describe the function, or that's one or two words to describe function of red blood cell, what would it be? Red blood cell. Two words only. Transport oxygen. Okay. White blood cell. Fight pathogens. And fight pathogen. Platelets. Function. Platelet. Blood clotting. Wonderful. Thank you. And blood clotting. Then plasma line for what? Transport what? Plasma. Okay, fair enough. Substances. Because good substance also transported in plasma. Bad substance also transported in plasma. Fair? Okay? Alright. Now, for your blood vessels here, I think this one everybody should be aware of this. Arteries. Away. Okay? Arteries always transport blood away from the heart. The veins will just be the opposite. Or you can also use the word the vein brings blood in to the heart. Okay, no exceptions. This way of remembering their names got no exceptions. Artery away from the heart. Vein brings blood in to the heart. Okay? Okay? Function of capillaries. Use one word again. Let's keep it simple. One word. One word. Wow, exchange. Exchange. Capillaries are for exchange. It can be via diffusion. It can be via osmosis. That's why I don't want to bind myself to one thing. Okay? Yes? Okay, so exchange. These two is transport. Arteries and veins are for transport. Capillaries for exchange. Okay? One of my favorite parts over here is about the structures of the heart. Please make sure you are able to recognize and identify all the structures there. Okay?
Remember the names of the valve.
You have to remember everything in the heart, except for this one. In your syllabus, there's no need to say superior. Pinang cover will do. Okay? Okay, Pinang cover will do. Okay, come, let's add in some labels over here. What is this part? Very good. Well done. Pulmonary vein. Let's look at this one. Bring it down. What is this? The dark green one. Nope. This thing, then you track back here. Okay, you know why you keep thinking of vein?
Isn't it? It leads into the right ventricle, so it should be the artery.
Yes. Do we see? Okay, so the idea here is when you are thinking, oh, vein, valve, but this valve belongs to the heart. Vein, valve, right, is when it's not of the heart. Does it make sense? All veins have valves, but these valves you're looking at belong to the heart. So that rule just now doesn't apply anymore already. Fair? Can we see that? So use the heart to identify. We look at this vessel, it is connected to this chamber. And this chamber is the right ventricle. Hence, right ventricle is out or in blood? Out. So this has to be an artery. What artery is this? Pulmonary artery. Pulmonary artery. Okay? Pulmonary artery. Let's talk about the valves now. Let's talk about the valves now. Over here. Between the left and the right ventricles. Left and right ventricle, no. Left atrium and left ventricle, yes. Bicuspid. Kessler, leave me first, Kessler. Bicuspid valve on the left side. What is the name of the valve on the right side? Tricuspid. Okay, two more valves. Where are they? Sorry? The semilunar valves. Okay, semilunar valves are named after the shape of their flag. Right? So it's like the doorway is the space. The door itself is the valve. Okay? So how do I differentiate the two semilunar valves? This one. The semilunar valves are named after the vessel it is connected to. The semilunar valve is named after the vessel it is connected to. So look at this valve and tell me what vessel it is connected to. The aorta. So therefore, do the same for this one. Do the same for this one. What is it called? Well done, Heiko. The pulmonary valve. Okay. Right, I have to go. I have to move on already. But next time we can revise a little bit more, and I can help you understand and remember a little bit more easily all the different parts of the heart. Okay, let's move on for. Later, yes, it is better for you to know the specific names of the semilunar valves. Okay. All right, red blood cell is the one that we are all the most familiar with. So not gonna spend too much time on this. However, I want to stress on this. Of all the features of a red blood cell, this is the most important one. Think about it. Hey, if a red blood cell does not have hemoglobin, then you got the biconcave, you got the no organelle thing. No point. It needs to have the hemoglobin to even transport oxygen in the first place. So that is the most important adaptation. Okay? Secondly, white blood cells. In your syllabus, you need to know these two. Because white blood cells actually is a name of like more than 10 different blood cells. Okay? So you need to recall that we have two white blood cells in your syllabus. The phagocytes feed. Phagocytes feed on pathogens. Maybe that's why they are fat. Okay, you can use that. Okay, so let's use that to help you remember. The name of this feeding action is known as phagocytosis. Okay, lymphocytes actually they don't do the fighting. They stand far away and they shoot arrows. Whereas for the phagocytes are the ones that actually at the battlefield looking at the pathogens. Oh, let me eat you up. But the lymphocytes stand far away. They shoot arrows there. The arrows are the ones that damage the pathogens. Okay, the arrows are the antibodies. Yes, Kessler.
Phagocytes are like Minecraft swords.
Yeah, correct.
Lymphocytes are like Minecraft.
Correct, right? We have the melee and the range ones. All right, so for the blood clotting stuff, players like Dini mentioned earlier on. Okay. Please keep in mind, I want to focus on the purpose. The purpose of blood clotting. I don't want you to come in. I don't want you to go out. What do I not want to come in? The bad stuff, the pathogens. What do I not want to go out? Good stuff, your own blood, right? Okay, simple as that. Very straightforward. All right. First one, I talked about that already. Blood vessels, we also covered as well about the directions. Okay. Structure. Arteries have thick walls. Purpose. Withstand. Wonderful. That's what I'm looking for. Withstand. Arteries have narrow lumen. What for? It's also for high blood pressure. Or what one? Just one word only. If thick is to withstand high blood pressure, narrow is to what? Well, blood pressure.
Regulate.
No regulation. Okay, very straightforward. Just 3 words to share with you for those two things. Arteries, thick wall, withstand high blood pressure. Arteries, narrow lumen, maintain high blood pressure. What is a lumen? Sorry? Come? The space inside any cylindrical tube. So in your esophagus, lumen. Small intestine, lumen. Large intestine, lumen. Oviduct, lumen. Everything is a lumen. It's a space inside. Okay? Lumen is just a space inside something. Okay? Okay. Okay, we talked about all of these already. Quick question. Why got two pulmonary arteries? Why got two pulmonary arteries? You see, it branches off. Cause got two? That's it, two lungs. You know that we have two lungs, right? One.
Very vague, right?
Yes. Wait, what?
Yeah.
Wait, really? We have two, Two.
Very sorry, never heard that before. One different,
Okay, the two lungs are not Identical. One is smaller than the other. Can you tell me which one? Right is bigger. Why? Why is left one smaller? You know one. You know one. Left is smaller because why? Don't want the entire the left lung. Yes, the heart one. You need space for the heart, right? Hey, okay. Can you all point to your heart now, please? I want to see where is your heart. Where's your heart? Got heart not? Jayla, got heart not? Point to your heart. Where's your heart? Hello, Jayla, where are you pointing? Okay, firstly, okay, come look at me. Hey, our friends online, have a look, This is my center over here. Okay, your heart. Every time last time primary school, your teacher say, "Hey, put over your flesh, put over your heart here." No such thing. Your heart is not here. If it's here, you are an alien. Okay, right? Find your center line. Where will it be? It will be the bony structure over here. If you can tap on it, it will be bony structure. All you need to do is take 2 finger spacing. That is where your heart is only. It's very, very central. It's just here only. Okay, it's not in your left chest. No such thing. Okay, it's just like 1 to 2 finger spacing away from your midline. That's where your heart is already. Okay? Ask.
Does glucose affect the position of the heart?
It can, yes. Okay, come, let's move on. All these parts over here, this is then what you're talking about. The left ventricular wall is bigger than the right ventricular wall. Just now we're comparing lung more heart. Okay, right? So all these points here, I have already done my best to craft it out into as simple an explanation for you to understand, such that if you can deem me fit, right, use this sentence in your explanation in school as well. Okay? That's your right. Left is there. Okay, last one over here. We're looking at the pressure graph. Okay. The pressure graph is incredibly important because it guides us on identifying when the valves open and close. First and foremost, the function of the valves is to do what? Thank you. Prevent backflow. Can we also think about it in another perspective? The valves close to prevent backflow, thereby ensuring
Once again, it pushes.
it will only flow in a single direction. Thank you. Keep that in mind. Okay? Right. So I want to stress again everybody's head. The only thing that the only thing that pushes blood, the only thing that pumps blood is what? The heart. Please never say that the artery is the muscular wall very thick to pump blood. No such thing. Whenever you think about the movement, right, it's always the heart. Okay? The vessels merely transport. Okay? Okay, so this part over here, I'm just gonna use this one over here, since on the rightmost I have the most space over here. Semilunar valve. If it's a semilunar valve of the left side, what is it called? Semilunar valve of the left side, what is it called? Left side. Aortic. Semilunar valve on the left side is the aortic valve. Okay, now the aortic valve closes to prevent backflow from. When the question says explain the purpose of the aortic valve closing, we cannot say prevent backflow. That's it. No. Tell me prevent backflow from where to where. Look at your diagram properly. The aortic valve closes prevent the backflow of blood from where to where.
Ventricle to the aorta.
Okay, if you say left ventricle to aorta, is that the correct direction? It is the correct direction. My goodness. Blood should flow from the left ventricle to the aorta. No need to talk. Look at the diagram. Blood should flow from the left ventricle into the aorta. Right now. So when I say, hey, how about let's not just say it, let's write it down. Aortic valve closes to prevent the backflow of blood from the
ventricle. Wait. Ah, I don't understand. Wait. Ventricle to the should be going from the ventricle to the aorta.
Hey, you don't understand this word not? No. Let's see whether okay, yeah. The aortic valve closes to prevent the backflow of blood from the aorta to the left ventricle. Aorta to left ventricle. Correct or wrong direction? Wrong. That's why I prevent lah. Hey, your English what?
I'm interested in children.
You want understand this sentence? Okay. Jokes aside, are we clear on this sentence now? Can you all adapt this sentence for like bicuspid valve for me? The bicuspid valve closes to prevent the backflow of blood from
the
bicuspid.
from the left ventricle to the left atrium.
Bicuspid closes to prevent blood the backflow from LV to LA.
Yes.
Make sense? Do we know how to use the sentence? Clear? Clear? Awesome. Okay. So this is the purpose of closing. But what makes it close? This is the purpose of closing. So purpose and cause different. So let's write this down. This is the purpose. Okay, purpose. What about cause? What causes it to close? I'll write anything down. You'll see whether you understand. Don't write first.
What is PV?
Yes.
Pressure.
No, I heard one word. What's it? What word do you say?
Pulmonary.
No. I heard the correct answer just now. Pressure. Oh, pressure. The purpose of closing is the backflow thing. What causes valves to open or close is actually the difference in pressure.
Answer.
Yes. Okay. So when the pressure of the aorta becomes greater than the pressure in the left ventricle, what will blood want to do? Blood always flows from high to low pressure. Just like you will want to move from a crowded room to a less crowded room. Okay, more crowded to less crowded. So how do I look at the direction? Look at this. Can we look at this inequality sign? Can we think of it as an arrow? So if we look at this arrow, blood flow from aorta to LV. Correct or wrong?
What does the T and
Okay. If I look at this arrow, this means that blood flow from aorta to LV. That's the wrong direction. Wrong direction means the valve will have to. That's it. Okay. So why? Purpose of closing, prevent backflow. What causes it to close? This pressure change there. Okay. All right. And these two things is applicable when you flip it around. Why open? All the same. Okay. Please make sure we are fully aware of how the diagram works. The heart structures there. Okay. Come, the last part on coronary heart diseases. Last part on coronary heart diseases. What does coronary refer to? What does coronary refer to? Heart, heart disease. So why coronary heart? Why not just heart disease? Why must coronary heart disease? Specific, yes, it is a specific part of the heart. Which?
Coronary.
What is coronary then? Can someone tell me what does coronary refer to? Yes, it's the vessels. What do the coronary arteries do. Just now we think arteries transport blood away. Coronary artery, blood away from the heart to the heart. What word do we use for lung? Pulmonary, So coronary arteries, let's be more specific. Coronary arteries transport blood from where to where? From heart to heart, cannot, right? I'm hearing correct answers here and there. What are they? We need to specify heart muscle. So is it from or two heart muscles? Two heart muscles, very good. So from where? Absolutely, well done. Let's pen this down. No need to pun, no need to pen. I already put it down here. Okay. Coronary arteries transport oxygenated blood from the aorta to the heart muscles. And it occurs from the outside. It occurs from the outside. So blood has to exit into the aorta first. Why? Very important. Blood that is flowing in the chambers are not available for exchange. Okay, blood flowing through the chambers, not available for exchange. Okay? Okay, so always keep this in mind. When the question asks coronary heart disease, you must say that the coronary arteries are going to be damaged. They are telling you to specify. Okay? So, as with any organ, if the liver, if the kidney cannot receive enough oxygenated blood, what process can occur? Oxygenated blood? Go. What? Respiration. Okay? If any organ cannot receive oxygenated blood, cannot undergo cellular respiration, cannot release, what's the purpose of respiration? Always tell me that first. Energy. No energy for cellular processes, the cell dies. Likewise, if the heart muscles cannot receive enough oxygenated blood, cannot undergo enough respiration, cannot release enough energy, the cells start to die. That is a heart attack. Okay? Why ask me instead? Ask me what? Okay, I'll move on. So if you look at this diagram over here, what are some ways in which the coronary arteries can be damaged is a blockage. A blockage. Okay? This is a build up, is a deposition of what? Fat and cholesterol. Okay, fat and cholesterol. Okay, the build up of fats and cholesterol in the artery is what causes it to narrow. Now again, this word you tell me just now already, but can you tell me again? What is this space known as? The lumen. Okay, so the narrowed lumen increases the strain on the heart because a narrowed lumen, less blood can flow, right? Will the heart muscle say less? Okay lah, never mind, less blood lah. No, right. So the compensation is the heart pumps harder and faster, but it's a muscle still. It will tire out. If you get to the point of exhaustion, heart attack lor. Okay, all right. Okay, that's it. Okay, that's it for both sciences. Let's go through the mock paper now. Okay. Okay, really quite wasted. The point of this thing is for y'all to go and try the mock paper one. Because I do not have time to go through every single question, every single point. Okay, so it's on you. We have to be accountable. At the end of the session, we will share with you the answer key, right? So just follow along with me for the analysis portion. Fair? Okay, follow along with the analysis. If you have an answer in your head, please share with me as quickly as you can so that you can move on. Okay, let's move on. This portion over here, just a comparison of properties, fairly straightforward. I want to immediately look at density. How do we know whether a gas is denser or less dense than air? How do we know whether a gas is denser or less dense than air? How to know? Is there a certain measurement I can make or calculation? There is. No, I don't want to. I cannot calculate density specifically, but we use this number to estimate the density of the gas. How do I know the density of air first? I give you all two things. For example, CO2 is denser than air. H2 is less dense. What do you say? No. Who is it? Who said something just now? Yes, thank you. My goodness, Joel. Don't think of girls, no. MR, not Emma. My goodness, Joel. Does he know Emma? Tell her he was thinking of her. Okay, come. Back over here. See, we can find love in science as well. Alright. CO2 is denser than air. H2 is less dense than air. What do we use again? MR. MR. What, Joel, is MR?
Emma. Periodic table a bigger number.
Okay, I like that. Periodic table the bigger number. Why? Because the bigger number is always the atomic mass, the AR. The small number is always the proton number. Absolutely, thank you. So CO2 has an MR of 44. H2 has an MR of 2. But then I'm missing one other value, isn't it? CO2 is denser than air. H2 is less dense than air. How do I know?
Air.
Yes.
Density of air.
I need to know the density of air, isn't it? But what is the MR of air? Is it possible to get that? What is air? So it's a mixture of gases, isn't it? But because nitrogen is a huge majority of 78%, right? We use nitrogen MR as an estimate. What is the MR of nitrogen gas? What is the MR of nitrogen gas?
Oh, just like that. Like, I got this.
This is what you see in your periodic table. Tell me, what is the MR of nitrogen gas? Hello, nitrogen. Yes, N2. 14 times 2, 28. Nitrogen, right? So we always use we always use 28 as our estimate for the MR of air. Anything greater than 28, denser. Anything lower than 28, less dense. Okay? Okay? So water vapor, denser or less dense? Water vapor, denser or less dense? Why? MR of water is 18. Okay?
Wait, oxygen is 16.
Hydrogen is 1. I have 2 of them. So 1 plus 1 plus 16 is 18.
Oxygen is 16.
Yes. Okay, come. Let's move on. Okay, question 2 very simple. I want to skip. Let's move on. Okay, this one. Recap. What state? What state? Solid. That's it. You just need to find something that's in a solid state at 22 degrees Celsius.
Yeah. Hey, what's the answer for question 1? Hey, excuse me, what's the answer for question 1 and 2? What are the answers for question 1 and 2? Wait! I don't think it is.
You see, I'm busy. Wait first, can
Sorry.
Come tell him where would the answers be.
Question 1 and 2.
Then I will.
Okay. I'm
Okay.
sorry.
Okay, come, let's continue.
I'm sorry.
Right, yes. Okay, vibrate around fixed position, solid. So you just need to find something that is in a solid state at 22 degrees Celsius. That's all. Okay, don't be confused with negative numbers. Okay, by now it shouldn't be anymore. Okay? Okay, why is aluminum Al3 plus when it becomes an ion? What happens to the atom? Does it lose or gain or share? Lose how many? Okay. What was the word I shared just now about protons? Because it is the identity. Okay, proton number cannot change. Okay, so it has to be of 13. The electron, if it's 3 plus, it needs to have 3 less. But neutrons, what is neutrons? Protons plus proton plus neutron gives me the nucleon number, the atomic mass, the AR. Very good. So what you need to do is look at your periodic table, you get the number already. Okay? Right? Questions like this, 3 marks, because the answer is literally in your periodic table. Okay? Let's move on. Okay, this one, recap. What does this tell me? What else? I'm looking for group what? In your syllabus now, new one, group 15. Okay, group 15, right? What does group 15 mean? 5 what? Trans. Okay. Very common error again. Let me address this together. Period number tells me the number of. What is period number? Number of shells. Why is it incorrect to say number of valence shells?
Valence, how many circles there are?
What is valence? If I don't use the word valence, what word do I use instead? Last one. How many last ones can you have? How many outermost can you have? One. Okay? So if you're using the word valence, number of valence, electrons. Period is number of shells. Okay? Okay? So these two things, 2, 5, 2, 8, 5, 5 valence, 5 valence electrons. This is okay. 2 shells, 3 shells. Okay? Okay? Okay, let's move on. I'll talk about, like I said, I talk about analysis only. Alright, this one. If we zoom into this, what comes to your mind? What comes to our heads now when I zoom into this? Ionic, very good. Remember the only aqueous that have? Okay, acid ionic, yes. Okay, and that's it. Very straightforward.
Wait, hold on. I have two questions. Why is the
Yes.
T lowercase the capital? And why is there no O?
Yeah, just a typo. Okay, doesn't matter. Let's move on. Based on the dot and cross, what does it tell me about Y and Z? Share, covalent. So what about Y and Z now? They are non-metals. Very good. Do we see that? If I see that they are sharing electrons forming covalent bonds, Y and Z are non-metals, so it cannot be your metals. So calcium is immediately out, isn't it? Right? What else can we identify? Y has 1, 2, 3, 4, 5, 6. So Y has 6. And then Z has 1, 2, 3, 4, 5, 6, 7. Z has 7. So what does it tell me again? Y has 6 electrons shown here. What does it belong to? Yeah. 6 electrons in it. Group 6. You're gonna find something that's group 6 over here, and then group 7 over here. Carbon group what? Carbon is in 14. My goodness. Okay, so out. So we're left with oxygen and sulfur. Carbon is in 10. Carbon is 14. It has 4 valence electrons. So between oxygen and sulfur, they are both 16, yes. So therefore, we're looking at the halogen. Answer is D. Okay? Right? Be able to distill out all this information from your diagrams. Okay? Alright? Okay, the next question I want to look at with you is, yeah, I think can. Question 9. Let's look at question 9 over here. UI turns blue. If UI turns blue, what pH? UI turns blue. What pH? Alkaline. Okay, alkaline, huh? Alright, so therefore what could be inside L and M that results in the alkaline nature? C is correct. Why? Why is it not? Why is it not? Why is it not A? Okay, you see, this one, no pH. This one is acidic. What will happen over here?
Neutralize.
A reaction will occur, right? The acid carbonate. So then what will be the gas form? What's the acidity there? What's the pH of the gas there? What gas is formed? Tell me. In acid reactions, acid carbonate, give me what gas? Carbon dioxide. What kind of a gas is carbon dioxide? Carbon dioxide is an acidic gas. So once more, it will become red. Okay? Right, so the answer is C, because this will release what gas? Ammonia gas, which is alkaline. Okay? Alright, this one is your acid-base reactions. Please make sure you're confident with it. Okay, this one very straightforward again. Right? We want to zoom into this. This one is your ZAP, your amphoteric oxide. So you have over here carbon dioxide. What kind of an oxide is it? Carbon dioxide. It's acidic. Therefore, that's our answer. Okay, carbon dioxide is acidic. Carbon monoxide is what? Carbon monoxide is neutral. Okay, carbon monoxide is neutral. All right. Okay, come. Question 11, very straightforward. Can just very quickly tell me one word only for part 2. If I'm looking for one word in your head that tells me why they have the same chemical properties, I shared that with you earlier on. No, electrons. Thank you, Ryan. Alright, especially for those that have not done it, these are the clues I can pen down for you first. After this, go back and find time to do it. Can? Alright. This one, if I write down, nope. Does it mean something? Does it mean something? 2 or 8? Okay, keep that in your head. Okay, straightforward. Let's go. You know what? Come, let's draw this together. Come, pencils out, please. Let's draw this together. Once more, Vaughn, what does valence mean? Outermost only. I only want to draw outermost. If I have, they give me sodium got 11, sulfur got 16. How? What is the first thing I should come up with? I want to write down my electronic configuration. Do what? Very good. And then sulfur is? Kessler, come write down electronic configuration. Sulfur is 2. Very good. So therefore, question only says valence. I literally only need to bother about the 1 and the 6, isn't it? Okay, first things first. Do they become covalent or ionic? Covalent or ionic? Ionic. Sodium is metal. Sulfur is non-metal. Alright, ionic, Okay. Who will lose electron? Metals always lose the electron. Okay, metals always lose the electron. Okay, question. In your school, for the case of sodium, right, when they lose this one, do you all draw in nothing or do you all draw this one next? Can you tell me? You draw the 8, right? Draw the full one, Okay, very good. So therefore, alright, pencils out, So basically, what you're gonna do here is literally just put an NA, draw as nice a circle as you can. My perfect circle. All right, and then as neatly as you can, make sure you're looking at 8 electrons over here. Square bracket it. So beautiful plus in the top right corner. That's it. Okay, and then for your sulfur, again put the S over here. As nice a circle as you can. Then you're gonna use a separate shape for it. Yes.
So big.
Yeah, immediately wrong already. Okay, gotta be aware of that.
Wait, how do I know if we have to do a covalent or
Covalent bonds are formed between what kind of atoms? Non-metals only. Sodium is a metal, Kessler. Sulfur is a non-metal. So if it's metal, non-metal is ionic. Okay, what am I left with? Sodium sulfide. What's the formula? Look at this. Look at this there. Sodium can lose how many electrons only? But sulfur need how much? Then how? I need 2 sodiums. What's the formula of sodium sulfide then? Very good. So instead of drawing another sodium, I put 2 over here. This means that I have now 2 electrons available to donate to sulfur, and therefore what's the charge of the sulfur ion here? The name of the sulfur is the sulfide. Yes.
same draw two sodium?
No. You're already lazy to draw one, I draw 2.
Okay, where it's hard.
Save yourself. Just save yourself time. Okay, very simple. If you draw one sodium correct, the other sodium wrong, you're wrong.
Yeah, this is
Yes, do this. Okay, makes sense, right? If you draw 2, you have another point of potential error to make. Just draw one, make sure it's nice. 2. Okay? Thank you for asking that. Okay? Anything else to put in here after this? The legend, thank you. Okay? Electron of sodium, electron of sulfur. Okay? Awesome, let's go. What tells me that this is a covalent compound? What tells me that this is a covalent compound? Thank you. The word di, remember? Monoditries tell me covalent. And of course, both are non-metals lah. Sorry, no, both are non-metals. Okay? Sulfur is in group what? Sulfur is in group 16. Is there something else in group 16 that you are familiar with that forms a compound with carbon? Oxygen. So what is the formula? What is the formula of the compound that oxygen forms with carbon? CO2. So the reason I want to put this in your head as long as the same group, similar what? Chemical properties. So if you know that it's CO2, then this is also CS2 lah. It's always going to be the similar formula. The structure will also be the same. Okay? Can conduct electricity or not? Why not? No. Here you must state both. No mobile ions or electrons to conduct the charge. Wonderful. Okay? Okay, this one. Everybody's favorite question. Standard one, this one. If I were you, right, I would rejoice at this kind of question. Very straightforward. You literally tell me what's the structure and what's the bonding. Therefore, gas and room. What's the structure of CS2? Simple covalence. Wonderful. What's the bonding that you're concerned with for this question? Am I concerned with the covalent bonds in CS2? Am I concerned with the covalent bonds in CS2 for room temperature? No. When it's a gas, state change. What am I concerned with? State change. Will the covalent bonds be involved? What else? What else? Come on, think please. Yes, about energy needed to do something. Overcome what?
charges.
One word in front. Yes, the intermolecular ones. Yes. Always keep in your mind. Hey, bonding. Do I talk about the covalent bond or the weak intermolecular forces of attraction? Always choose intermolecular forces of attraction for state changes. Okay? So this one we're just gonna append down as a clue for those who are gonna try later on. This one we're gonna talk about simple covalent structure, and this one is what is that for again? Intermolecular forces of attraction, yeah?
If I write like the giant crystal lattice in
But this is simple covalent. That's immediately wrong already.
but
Yeah, then that's for structure. Okay? Awesome. Thanks for clarifying. Okay, moving on. Wow, free mark number one. Type of reaction. Sorry? No, that's an observation. This one actually no specific name. You just tell me what are reacting together. What are reacting together? What is magnesium? It's a metal.
A metal, yeah.
So this one is literally acid metal reaction. It's just an acid hyphen metal reaction. Okay? What causes soil to become acidic? If you were to pinpoint one particle that makes soil acidic, what is it? Particle. What one singular thing makes soil acidic? The other one? Hydrogen. What makes acid acid? H plus. So why am I bringing this to your head? If H plus is the one that makes soil too acidic, how do I reverse it? Which one is the specific particle? Hydroxide. It's the hydroxide that neutralizes the H plus, isn't it? Fair? However, I will actually take one step further to tell you that hydroxide is the second choice. I would much rather add carbonate. You know why, Jalen? Can you share with us? It's okay, use your own words, come. Share lah. Wait, what? Okay, first choice is always carbonate. Now, let me tell you right now. Imagine you are a farmer slogging your back out, tilling your land. Acid rain comes. Do you know how much acid is in your soil? Do you know how many moles of H plus are in your soil right now? Let's say you're a world-class chemist, very good at mole calculation, but are you able to calculate how much H plus is in your soil? If you do not know how much H plus is in your soil, how would you know how much OH minuses to add? If I add too little, my soil remains acidic. No use. If I add too much, how? My soil now becomes alkaline. Still not good for my crop as well. But why is carbonate our first choice? Carbonate usually is in the solid form. If I scatter the carbonate powder, the moment it disappears means it's reacted with the acid. If it keeps on disappearing, means still got acid to react. I keep pouring the powder until the powder stops dissolving. Then the excess got any harm or not? It's just a solid one. Just gonna get watery later anyway. Carbonate will always be the better choice. But will we be marked down for adding hydroxides? No, because it still can get the job done. Okay? Question is simply asking you what can the farmer add. Question not asking you what's the best thing the farmer can add if he doesn't want to do more calculation. Okay? Okay? Hydroxides and carbonates will both be. Always remember, be able to pinpoint what causes the soil to become acidic. H plus. Okay? Okay. Okay, come. Let's move on to our bio portion already. Okay, this question pretty straightforward. I want to look at this question. What a beautiful diagram. Okay, I'm gonna use this opportunity to have you identify some labels for me. So let me eyes on screen over here. I'm gonna look at the right hand side. I will label blue, green, orange. What are these three structures? Can you help me, please? Is it? Wait, actually, can you don't write first? Don't write, don't write. And then what is that? Orange is what again? Is it? No, I said don't write first.
Cytoplasm.
Okay, because only got one correct. Which is the correct one? Only cell wall is correct. Only the blue cell wall is correct. Why?
Oh. You didn't know I did that. You didn't know you did. You know what blood this is? You know
What is green then? It is still part of the cell wall.
what?
Why am I bringing this to your attention? Okay, after you write this down, then let me your eyes on screen.
Because cell wall maintains the shape.
Okay, you're giving me a fact here, but you're not explaining this portion. Give me a sec. Why am I bringing this to your attention? Because the cell wall, how does it maintain the regular shape, protect the plant cell? What does it contain? Cellulose. The very fact that it contains something means you need to have a space, right? Space. The cell wall is the space. So when you draw, what's the name of this cell here? What's the name of the condition here? What word will you use? Plasmolyze. You see plasmolyze over here. What's the opposite of plasmolyze? So again, this one don't draw. Just look at. Let me your eyes on screen, please. Okay, look at these two diagrams now. How would I label my cell wall and cell membrane now? My cell wall will be this one. My cell membrane with the inner line. So why just now I cannot label the inner line over here? You must understand. In this diagram over here, technically, if I were to use pink for my cell wall drawing, this is cell wall. If I were to use red for cell membrane, is this. Does it make sense for you to draw two lines overlapping each other? Because in a fully turgid cell, the cell membrane is fully pressed up against the cell wall. Can we see that? So in a fully turgid cell, you will label the innermost line, the inner line as the cell membrane. You will label the space as the cell wall. But when it's plasmolyzed, when the cell membrane has separated, pulled away from the cell wall, you cannot label this as the cell membrane. The cell membrane has pulled away from the cell wall. Do you see that? Okay? Alright, so be aware, cell wall, cell membrane. Let's not throw away such an easy one mark here. Clear? Okay? Hang in there, people. Hang in there, hang in there. Alright, what process am I thinking of that results in the plasmolysis of a plant cell? What's the name of the process? Osmosis. So it moves from higher to lower water potential. Okay? Right, so we are looking at the a lot of water enter or exit? Exit. So water potential is lower than the inside of the cell. So water must exit. Can? Okay? Okay, let's go. Let's move on. Okay, question 3. Think about what Rayanne enlightened us with earlier on. What does saliva contain? Salivary amylase is? What is salivary amylase? It digests starch. What is it? It's an enzyme, and therefore, what test? The puree. Very good. Okay, so that was what Ren helped us with earlier on, isn't it? Okay? Anything else present in saliva? Anything else present in saliva or not? You taste your... Is it sweet or not? If it's a yes, something is wrong. Should not be on. So therefore, no reducing sugars. Okay, no reducing sugars. Ethanol emulsion is stands for what? Fats, so no fats. Okay, so please remember the colors. Negative, positive, negative. Small intestine. Primary function of small intestine is to do what? Then digestion and absorption. So if small intestine become completely smooth, which one does it affect? Digestion or absorption? Absorption. So if it becomes smooth, is it better or worse at absorption? So what happens? Malnutrition. Well done. Okay, malnutrition. Everybody's favorite now again. Let's go. If you did not know, atria is plural for the atrium. Okay? When the atrium contracts, where does it push blood into?
The ventricle.
Very good. The atria will force blood into the ventricles this way. Look at my two arrows here. This is the direction of blood flow when the atria contract. Question is asking, what happens to the valves? Question is asking what happens to the valves. Z must open, right? See, correct blood flow, okay? Where is Z? Z is open. Oh, what am I doing? It's just this. Okay? X must open or not? X is this one also. So thing is X. X must open also. Okay? Then how? What is the name of valve Y?
Aortic.
Which semilunar is it? Is it the aortic or the pulmonary? The aortic, very good. Aortic, in this case here, open or close? Must close lah. Okay? Okay? Let's go. Okay, bonus question from infectious diseases. What is this? What is a vector? What is a vector?
A, B, E, C.
Hey, don't math here, don't math. It's been a while since I math already. Come, in this topic, what is vector?
Vector.
Pathogen.
What is the pathogen that spreads these two diseases? So influenza, what is the pathogen? Virus, thank you. Influenza is virus. What is the pathogen for pneumococcal disease?
Wow, bacteria.
Bacteria. And hence the question is asking you to compare virus and bacteria. Do both have cell wall? Which one has?
Bacteria.
Bacteria have cell wall. Both have nucleus, yes or no? No. What is the nucleus? Virus, no nucleus. A nucleus means genetic material protected by a nuclear membrane. Virus don't have nuclear membrane. Okay? Both have genes or not? Both have genes or not? What is a gene? Genetic material lah. Then both have genetic material or not?
Right.
Yes.
Okay.
Thank you.
Oh. Why do they need to leave?
Okay, wait. Come, let's write down. We're gonna write down below each column. Both have cell wall is no, because only bacteria have. Both have nucleus is no. virus and bacteria, both no nucleus. Okay? But do they have genes?
And spread.
Okay, very important. Both have genes. Both have genetic material. Wait. If bacteria no nucleus but have genetic material, can you explain that to me, please?
So I don't know.
Simply put, our cells, our genetic material is protected by a nuclear membrane. Bacteria, the genetic material is just that. Yes, literally. It is. Okay, not inside a nucleus. It is just in the cytoplasm.
See.
Okay? Last one. Do they both respire? Who does not? And hence, so is D, okay? Okay, question 8, very straightforward. It's about composition of air. Okay. Question 9. Why? Think back to the last time you ran for the bus or did 2.4 or whatever. The moment you caught up to the bus and stopped that vigorous activity, why are you still panting? What is it for? You cannot just give me the name. What are you trying to do? When you still very good. I'm trying to break down that lactic acid by maintaining a high oxygen intake. Right? Okay, that's why our graph, you follow my laser over here, it goes up by exercise, it doesn't just do this. There's a gradual thing. So the repayment of oxygen debt is in D over here, the increased oxygen intake. And where is lactic acid broken down at? Thank you, the liver. Hey, question 10, I just told you the answer. Come tell me. Influenza is pathogen. What pathogen? Virus. Then how? Reduce transmission. Vaccine. Antibiotics is for what only? Very good. Only. Please write down for. Only for bacterial infection. Okay?
Okay.
Awesome. Right, again, I'm just gonna walk through the analysis with you. For this question, can you very quickly help me to figure out change in mass? Why got positive and negative change in mass? What does a positive change mean? It gained, it became heavier. Negative change is it lose. Why will a potato strip become heavier or lighter? Very good. Thank you for immediately coming to osmosis. For these kind of questions, 90% of the time, osmosis. Okay? This is my tip for you. Most of the time, such a question, even though they say concentration of sugar, do not get duped by this. Most of the time, it's about osmosis. So if the potato strip got heavier, osmosis in what direction? Okay, into the cell. Okay, what does this triangle represent? Sorry, gradient. Thank you. Okay, down the gradient. If I add this thing, can you tell me what this is? Think of a definition, please. Think of a definition, please.
Diffusion distance. Rate of diffusion.
Partially permeable membrane.
Wow.
So why am I trying to bring this to your attention? Because movement of substances answers are 80% of the entire chunk of answer comes from your definition. Literally. Comes from the definition. Come, Lucas, define osmosis is the
这个concentration，因为这个 body permeable membrane
Down.
down concentration.
Wow.
No, down water potential.
Okay, water potential gradient. Always remember that. Okay.
Huh?
Okay, so if I know
I don't know.
Okay, basically, in the definition of from a region of high water potential to a region of low water potential, only for definition, then you use those phrases. If it's an explanation question like here, don't say the word a region of. Say from the solution which has a higher water potential to the potato with a low water potential down the gradient.
I always say this.
No, that's for definition. I'm saying now when you're adapting it for an explanation. Okay, so you're always trying to show direction. You're always trying to show direction, isn't it? Okay. So for example, let's see. If I were to just share with you wait. Let me open up my full curator notes. Let me just show you something. Okay, if you look at this, this is just what I teach in my class, right? How to explain for osmosis or diffusion. You always state where got higher or lower, what is the thing that moves and in what direction, and therefore across the membrane. This is the format I always teach for answering movement of substances questions. All right. Okay, so on the left side, what will happen? On the left side, what will happen to this diagram? How will this diagram differ? Oh, what will move around? It's just this only. That's it. Right, so you can see that on this side, excess water exits the cell. So the cell has a negative change, positive change over here. So why will C have the largest change? What does it tell me about the solution it was placed in? Very good. This one had the lowest concentration and therefore the highest water potential. A lot of water entered the cell. Okay, that's gonna keep that in your head. All right, let's move on. Fairly straightforward. So this is related to a question that Summer asked earlier. Summer asked if no gallbladder, how? This one is if no pancreas, how? Now, a typical question of bio is, if this organ removed or damaged, what will happen? The first thought is, what does it do normally first? All right, so for the pancreas, it has its digestive role. Digestive role. How does the pancreas play its role in digestion? The enzymes. Okay, then the other function is regulatory role, right? What does it release? Insulin and glucagon. All right, you're gonna see what the question is asking. Question is asking for diet. Then you talk about the digestive role. Can focus on the question. So this one is asking about the enzymes. No pancreas means don't have the pancreatic enzymes. The person must eat less, more of something. All right, think about that. Okay, moving on. Identifying the structures of the heart again. By now, we should be excellent at it. Now, what? Aortic regurgitation. New thing, isn't it? Aortic regurgitation, new, right? But the reason I want to put this over here is my opportunity to share with you. I could even, don't put those words, I can say phenomenon X. Can you still answer the question? Can what? I tell you what it is. Hey, pay attention, please come. I'm telling you what aortic regurgitation is, isn't it? So the name doesn't matter. All I need to do is tell you what it means. Say, the aortic valve weakens, cannot function properly. What is the function of the aortic valve? What do we write down just now? Of
the
blood from? Thank you. So therefore, if the aortic valves will prevent backflow from aorta to LV, then cannot function, then backflow will happen. Backflow will happen. How does this affect? So if you look at this diagram here, this is the aortic valve. It should snap shut so that blood will stay here. It cannot go in this opposite direction. But now there's a hole.
Yeah, correct. So that's more control.
Excellent. So therefore, what happens to the amount of blood exiting the aorta? Less. Because every time the LV contracts, it pushes 10 units of blood out. The valve will close to ensure all 10 will continue flowing out. But because the valve now cannot close properly, 10 goes out still, yes, but 2 can come back. So what is the overall exit? Only 8 ma. So the rest of the body last time get 10, now get 8 only. What happens to the rest of the body? Like what Kester mentioned, the cells cannot receive enough oxygenated blood. You see that? So therefore, question is asking, volume of blood flowing through, more or less, decreased volume, isn't it? Effect on the body, less oxygenated blood, less process. What's the process? Respiration, less energy. Okay? Awesome. Thank you for thinking about that. And for the arteries one, question only asking for one. Just now we already talked about 2 already. First of which Rayan gave us. Arteries. The thick muscular wall. What word do we have in our heads? What about the high blood pressure? Thick is with stent. Narrow is wonderful. Thank you for remembering that. Either one of those for part C. Okay?